Hi, and welcome to AI, Artificial Intelligence, part of the Voice First FM podcast network. My name is Bradley Metrock. I am CEO of a company called Score Publishing based in Nashville, Tennessee. We own and operate Voice First FM. In 2019, we are doing something a little bit different with AI. We're going to have a number of experts across the world join us for episodes that should be about to the cadence of once every couple of months. We are thrilled to be joined today by John Ball. John, say hello.
Good morning, or good afternoon.
Hey, good evening over here. Good morning in the land down under. It's all good. So share with us who you are. You're a fascinating guy. Who you are, what you do, who you do it for. Give us your background.
Okay, well, it starts about 1984, so I'm a lot older than I look, or I'm being polite to myself. But I was challenged by my university professor in computer science, who said we can never recognize human language. It's just too complex of a problem. The brain is too complicated. So for a reasonably lazy guy, I then have dedicated the rest of my life to proving her wrong. And the biggest challenge initially is, what is it that brains do that we're not doing with computers? There must be something fundamentally different there. And for me, the conclusion was that the brain is pattern matching, and the concept of the way we store information in computers isn't aligned with what the brain's doing with patterns. But I'll just take a quick step back, because otherwise I'm going to finish up really deep and everyone's going to be confused as to who I am. But So John Ball, I'm the founder and CTO of Pat.AI. We set up the company in the US in 2016 after having a research function in Australia since 2006, but moved to California in 2016 to set up the corporation. The interesting thing for me when you look around the world, though, is what's happening with what I call natural language understanding, NLU, because NLU should be about what people mean when they're saying things. And what the technology giants have done now, and all of them, they're very focused on these concepts of brute force neural network statistical systems, where groups of words then get categorized based on their likelihood of being in other documents, and then you can use that for various things. And a lot of the applications are amazing that come out of that. But for language understanding, the complicated way of explaining what NLU is that you understand the meaning of a word in a sentence based on the meanings of the other words in a sentence. So it's a different concept. The words themselves don't really play a big role other than to identify the meanings, and then it's the combination of meanings that produce the correct interaction. So for a voice podcast, for people interested in how voice first in AI will work better, it comes back to some things talked about in the 1960s, because all of my work seems to track back to the 50s and 60s when it was a formative environment. And the concept back then was that, we're unable to ever produce a phonetic typewriter, so automatic dictation, if you like, without having a machine that understands language as well as a normal speaker of that language, a native speaker of the language. So that was John Pierce, head of Bell Labs at the time, who was really stopping a lot of the crazy research that was going on in the community, saying we can solve this problem with whatever it was, and then getting lots of funding and then not achieving much. And at that time, with the government funding that was behind it, it wasn't a good use of taxpayers' dollars to keep funding interesting concepts that then were never leading anywhere. So my interest is in changing that by introducing NLU correctly, which is based on that definition I gave you, understanding the meaning of what people are saying and then manipulating that in conversation with true context. So is that a good intro?
Yes. Yes, it is. So obviously you're quite accomplished. You've been thinking about this, doing this a long time. I was struck by one of the things that you sort of commented on in the emails exchange leading up to this. You said that with Alexa, and probably it's true with Google Assistant and Siri and some of these others, some of the speech recognition, the advances in the speech recognition a lot of the positive gains that have been made actually stand in the way of greater, understanding, greater context. Maybe dive into this concept of the path that Alexa, just using that as an example, that Alexa is on, maybe isn't taking us straight to where we need to go.
Right. So we got an Alexa just to experiment with its capabilities 12 months ago, probably, and started to use it for the obvious things like asking what the weather is, and then started keeping track of grocery items. And the thing that struck me very quickly was as soon as you started adding compounds together, so I want bacon and eggs and bread. Once you got those compounds, you're now exceeding the capacity for the corpus linguistics to work. So the way systems have been working since the 1990s is we put more and more information into documents, we categorize them, and then we extract statistics from those documents, whether it's parts of speech for a parser or other types of information that we can then use to produce useful AI systems. And what I found was that with compounds, there's a very low likelihood that you're going to find that compound in any of these corpus documents, which means you then can't match the pattern. And so the system's now got to rely on some other technique in order to work out what you said. So if you were using an Alexa and you said something like, I'd put on my shopping list some bread, sausages, and steak, it would, in some cases, when you said what's on my shopping list, it'll say bread and steak sausages. Now, steak sausages wasn't what I said, and it has no meaning for the system. But with the technology doing a very good job at picking up what the words are, it's still doing a very poor job at what I meant by that. And it probably goes back to when Siri was first released, because you could obviously play some funny games with Siri, because it also was working with a very good speech backend. And you'd say something as a very long sentence, and it would very accurately transcribe what you've just said, and then completely get confused about what to do with what you've said. So for me, the NLU is that conversion from the sequence of words into the meaning that those words represent. And the variety of applications we've got is so immense that you need a generic solution for NLU, not a point solution for each domain or something.
We, at the Alexa conference, had two speakers, and they were back to back. The first was Katie McMahon of SoundHound. Are you familiar with any of their work?
Yes.
Okay. And, she was, her entire talk, she's great, by the way. If you haven't met her, you should. Her entire talk orbited this demo, this concept and subsequent demo of what she called and what actually is compound complex queries. Mm-hmm. And so she showed off, they're big on the car. She's actually keynoting our Voice of the Car Summit, which will be Tuesday, April 9th out in San Francisco. Shameless plug.
Oh, great.
But she walked through a demo basically that showed, I want to go to a Chinese restaurant that's within 5 miles of my house, that has 4+ stars on Yelp, that has a kids menu and closes after 8:30 p.m. And it just computed and popped up a result, and that got some oohs and ahs, and it sounds like well, and then the other talk that was right after that was a guy named Brian Romley. Have you met him?
No, I haven't.
Yeah, oh. You definitely should meet him too. He gave a talk. He's a real futurist. He worked with a lot of folks who worked with Bell Labs. There's a lot of connections there. But anyway, he gave a demonstration of something he called Intelligence Amplifier and My Wisdom Keeper. And these things were it polarized the audience, because the audience was thinking about Alexa, not necessarily thinking about something that's that far down the road. But to him, the inevitable conclusion of this path that we're on with voice first technology is computing that is so context driven and so personal that it's able to talk to us and inform us better than our own mind can inform ourselves in some cases. And then it's keeping up with this so much that after we pass away, there's a whole lot, almost an entire representation of ourselves that's left over for people, for younger generations of our family or whoever has access to that. It was kind of wild. And I bring up those two examples that are fresh on my mind, top of mind after the Alexa conference, just to, I guess, pose the question to you. You sort of touched on it in what you said a minute ago. You could take what you're doing with Pat Inc. and Pat.AI as a website. We'll link to that in the show notes. You could take what you're doing with this meaning as a service, which is how you've branded this thing, in almost any different direction. What is your North Star in terms of how you're spending your time, developing the system you're working on and just ensuring that you're not going down some rabbit hole? How do you prioritize what to work on in this massive realm of possibility called AI?
Yeah, look, that's a great question. And what we've been doing for the last few months is just focusing more on chatbot technology. When you think of what a chatbot is, an interaction with some sort of system, maybe it's a help desk, or maybe it's a billing application, whatever it is. There's a couple of things that it needs to do. One is it needs to ask the person it's talking to make certain statements. Welcome to my website. What can I do for you? And then based on the response, you want to get into some different environment. Maybe that's where they do the technical help, or that's where they do the billing help. And then the types of questions and things it's looking for is different at that point. So for us, focusing on chatbot seems to be a good application focus at the moment, because the types of things people say tend to raise a lot of frustration. If you did the online version, press 1 for this, 2 for that, 3 for this, 4 for that, and then you press 1 and then it says 1 for that. It's very frustrating. Whereas if you can go straight to the target you want and then get something that is genuinely helpful for you, that's going to be better for customer satisfaction in the immediate term. So that's what we're looking at. And when we looked at how we can help generally people in the space, because we're competing with what's known as word vectors and deep learning applications as a general platform. What we found is that the simple things that machines should understand are the things that are being missed. So when there's a little bit of subtlety in what we say, and people tend to then rephrase it and dumb it down. But my argument is machines aren't going to tell us how we're going to communicate with them. People are going to force the machines to communicate the way we normally do. So, the initiatives of places like, so SoundHound and Bell Labs and Google, all of the big companies are working and getting some pretty amazing results in the things that they're doing. But we argue that fundamentally the science doesn't support what they're trying to do. So everything has to be some sort of compromise. And the easiest way of explaining what the difference in the science is since the 1960s, people have focused on things like parsing and parts of speech. And, sorry for your audience if I'm going down this little rabbit hole, but it's a short rabbit hole.
No, you're good. Keep going.
So the idea of parts of speech is it's actually a very ambiguous element. So for instance, we talk about a noun, and a noun is, person, place, or thing. That's what you're taught at school. But the reality is a noun is also any other action. So the running of the race, the running in that case is the noun. So we're converting things which are referents, things we refer to, and predicates, things that relate things, as the one object. And so what we've done is we've split that out, and that's due to the linguistic science from Professor Robert Van Valen, who came up with role and reference grammar. And there's a good story that goes with that, and I might get back to it in a moment. But fundamentally, if you change how the science works from this thing that requires massive amounts of processing to a simpler model that doesn't have a combinatorial explosion, and it doesn't have it doesn't have the need for statistics, then we can start to handle language as people speak it, with all of the faults that we introduce to sentences and so forth. So I find that pretty exciting, and I don't think it's a big change for the tech giants to start to apply the principles that we're really publicizing, because RRG has been talking about this stuff for 30-something years, and it's just that it doesn't fit in very well with the mathematical models we're using. But I think we're getting close to the point where people are going to say, well, that's great. You know, we're doing well with image recognition, and we're doing well with some of these types of voice applications, but these other types of voice applications just aren't improving. And that's the point. You have to go back and challenge the science and say, well, what's different? And it's, well, we're not putting meaning in as normal people would expect meaning to be.
I got two more questions for you. This is fascinating stuff. The first one is, last year we got into this whole flap with Elon Musk and Zuckerberg. Pretty sure those are the two. They were going back and forth talking about, not to each other, but through the media, about the things that concern them about AI. And that's really my question for you. So you have the unique perspective of having watched, this sort of slow, gradual march up the tech curve. And then now you've seen this explosion of stuff going on, with Alexa, Google Assistant and everything, and Siri and Cortana, all the others. What concerns you the most about the future of AI? Is it data being manipulated and abused? Is it Terminator showing up? Is it something else entirely? What concerns you, John Ball, the most about what you're doing?
Well, interestingly, Isaac Asimov had some pretty good thoughts on this, and he came up with his 5 laws of robotics when he was writing his books in the 50s and 60s. And because as I said earlier, I'm kind of an old guy, so I remember that writing and his books. So he wasn't so much concerned about computers or robots taking over the world as people are today. But the basis of his theory is that there were these 3 laws of robotics: thou shalt not harm a human being, and et cetera, et cetera. But because they were written as, in this case, English rules, the question was, how would the machine interpret those rules? And a lot of his books were exploring what would happen when the robot decides that it's better to kill or enslave humanity in order to protect other humans. And then it was just making these decisions. So if we now fast forward to the present, we have this technology which is statistically based, and you can put information into a system and it gives you an answer. So let's say you're a self-driving vehicle. It's going along the road and a dog steps out in front and the vehicle stops. Inside the neural network or whatever system is driving that, if it stops, the question is why, and it's not necessarily obvious why. If it was a person in the same situation, they'd say, well, I saw the dog walk out and I didn't want to hurt the dog, so I stopped, which meant I pressed the brake pedal and stopped accelerating and so forth. So people would be able to give you all of the steps that were involved in coming to the correct conclusion. And today's systems don't do that. So if I was an Elon Musk and I see this big network that's had all of these documents loaded into it, and it gives me an answer, and you think, well, okay, that answer was okay, but do I trust that answer? And you say, well, why do you give me that answer? It says nothing, because that's not how it's built. So as we go towards NLU-based systems where the system understands why it's making the decisions it does, and it gives you its rationale for it, then people will get confidence in those systems. And the types of things that Asimov foretold 60 years ago can come true, because you can put the meanings of what the robot needs to comply with inside its own memory. And assuming that it's not allowed to do things that are against what are in its own memory, then we have good AI. So that's my argument against the doomsayers, because I've got to say, if you were to put a network you didn't understand in charge of our missile defense system, and it were to launch missiles, then you'd really want to know why it did that. And obviously, if it's in charge of that sort of system, you're a slave to that technology, and that's not a good feeling for humanity, for humans.
Well, now you're talking war games. Have you seen war games?
I don't recall.
Yeah, yeah. If you have not seen that, it's classic from the 80s. Yeah, you're reminding me of a paper I read, or at least I read most of it. I read what I could understand, and it was talking about connected cars, sort of like what you were just talking about. But one of the examples in the paper was in this realm that we're going to be in eventually of connected cities and smart cars and AI, informing all of these systems and this infrastructure. What are the algorithms that are appropriate for a situation? If there's an accident on the highway, something happens, and the computing around us has a split second determination on this person over here is going to die, or this person over here is going to flip off the road and die. And this person over here is 90 years old. This person over here in this autonomous car is 12 years old. What do you do? Or this, then this 90-year-old is Mother Teresa. This 12-year-old is, made an F on his test last week. I mean, there's incredible ethical implications with all this stuff that we're doing. And you talked earlier at the beginning of the show about getting the computers to model our way of thinking. I don't know how you do that. That's going to be a challenge. It's going to be a challenge for somebody. I want to conclude by asking you one more thing. It's not like we're going to settle this right here. It's just going to be something that we see how society decides to approach it. But I'm also fascinated, in addition to the ethical stuff, I'm fascinated by the way that different companies approach the monetization of AI, and like trying to package it up and sell it out as a widget or sell it out as a service or whatever. Some companies, it appears, are taking the approach, we'll just build some AI, we'll do it, we hope better than somebody else, and along will come an acquirer, and that'll be that. Other people are taking different approaches. I just want to ask you, what is Pat's approach, Pat.AI, Pat Inc., what y'all are doing? How are you selling what you're doing, if you are selling it? And what do you think is the best approach to monetizing what's going on? Obviously, you're working with chatbots. There's money to be made, especially if you can prove that you're improving, you're showing improvement in the customer experience. Walk us through the monetization of all that.
Well, there's to my way of thinking, it's not a short-term path. It's a new technology that we're working on that basically centralizes the meanings of all of the world's languages into one place. And then for each language that we add, we connect to that same meaning repository. So it's a language-independent meaning system. And applications should run off the meaning, not off the language. So as we add new languages, if it already works for some application, it's going to work once the new language is connected to it. That's the concept. So we're effectively building a universal dictionary with the specific language components that connect to it. So for us, the monetization in the longer term is to produce this useful repository. Sort of like Google has an amazing search index, which then gives us documents very quickly, and it's very well developed, and it's usually somebody's first choice if they're trying to find information. So for language understanding, we're expecting this would be the same result. And then as we add extra languages, at some point, you're covering enough languages for the general developer community that you're the default choice for this. And we at some point, there'll be competition coming to in the form of the tech giants trying to compete head on with us. And that's when we know that we're being successful in that. But for the monetization, I think I'm just happy to provide better services, and with the aim of leaving this world with AI in a much better place than it has been while I've been alive. Because the things that still frustrate me is I'm not interacting with machines like in 2001: A Space Odyssey. You want to just be able to talk to the machine, have it interact with you, get the right answer, and then do what you want. And we haven't gotten there, and I see our platform as being the way to help humanity get to that point. So, it's not as much a dollars-driven thing as it is a service thing and improving the world for the next generation.
If you're creating computing to interact with humans like 2001: A Space Odyssey, man, you keep that to yourself.
Not quite what I meant.
No,
now I'm in
that's
trouble.
perfect. That's perfect. John, thank you so much for this time. Thank you for sharing some of your time with us and some of your expertise and your deep experience with us as well. It's greatly appreciated.
It's been a pleasure, Bradley. Thanks for having me on.
For AI, Artificial Intelligence, Voice First FM, I am Bradley Metrock. Thank you for listening. Thank you for watching this if you're watching it on YouTube. Until next time.